Hello everyone. In this video, we will solve for first order differential equation using separations of variable. Differential equation is an equation that contains derivatives of the differentials. For example, dy over dx plus 5x equal to 2y is the first order differential equation. d squared y over dx squared minus y equal to 5x squared is the second order differential equation. So first order differential equation involving the first derivative. Second order differential equation involves the second derivative. So what is the solution for a differential equation? A solution of the differential equation is the relation between the variables that satisfy the differential equation. The solution is called the general solution since there are two independent constants. In this video, we will only work with solving for first order differential equation, and the method that we are going to use to solve for it is called the separations of variables. The general step to solve for the first order differential equation is we are writing the equation in the differential form by replacing y prime by dy over dx. Because we are using the method of separation of variables, then we need to manipulate the equation so that we can separate the variables. So x with dx and y with dy. Integrate both sides of the equation, and then we add the constant c1 to one side, constant c2 to the other side. Step number 4 is to simplify the answer. It is often expressed as the term with the variable x or the variable y which stay on the left side of the equation. In this case, it's called the implicit form, since it may be impossible to solve for y. Then you replace for any multiple of c, which is c, and then it stay on the right hand side of the equation. So let's start with a very simple differential equation. So in this case, you see y prime. So that means you are solving for the first order differential equation. Okay, so we are going to follow the step. So we have 5x squared divided by 7y. They call differential equation because it's involving the derivative of the differential. It's called first order. It's because you are dealing with the first derivative. And we are solving for the general solution. Therefore, the solution will have a constant c. So I laid out the step on this side. We will replace y prime by dy over dx. Separate the variable. Separate the variable means that you should have dx with the term that has x in it, and you have dy that together with the term that has the y in it. And depends on the operation that you have here, you will rearrange the variable logically. And then we integrate and then we simplify. Okay, so for this part, the first thing I'm going to do is I'm going to write this as dy over dx and then equal to 5x squared over 7y. So take a look at this ratio. You have dy over dx, 5x squared over 7y. So what you can do in this case is separation of variables mean you want to have the term with the dy's to go with the dy. And you have the term with the x to go with the dx. Okay, so term with y, which is 7y, will somehow associate with this dy. So what you can do is you can cross multiply. Okay, so when I cross multiply, I end up with 7y times dy equal to 5x squared times dx. Okay, so now you see that you are having this x squared with dx, and you have the y with the dy. After you have this, you are going to integrate both sides, because integration is an operation in calculus. So if you apply an operation to this side of the equation, you do the same thing on the other side. So you integrate both sides. Okay, so just like whatever operation that you apply to one side of the equation, you do the exact same thing on the other side. So why do you need to separate the variable and have the term matching with each other here, because if you integrate 7y, you must have dy. Okay, so the integral must have the differential factor, and then the differential factor dy will have to indicate that you integrate in terms of y. In this case, the same thing. So you have differential factor dx. That means you will have 5x squared as the part of the integrand, and then you integrate this 5x squared in terms of x. Okay, and then we can go ahead and integrate, because we have learned how to integrate this already. Okay, so then I will bring 7 across the integral sign. Then I will have a y dy. Okay, so this part I will bring 5 across the integral sign. I will have x squared dx. So the integration means that you add 1 to the exponent, you divide it by the result. Okay, so I have 7, and I will have y squared, right, divided by 2. So that means I multiply by a half. Okay, so I multiply by a half. Divided by 2 is the same thing as I say I multiply by a half. And then you plus c1 on this side. So the same thing here, you are going to add 1 to the exponent. That will give you x to the exponent 3. And then you divide it by 3. That means you multiply by 1/3. And on this side, you are going to write plus c2. So what I'm going to do now is I'm going to ask you to rearrange the term, because you have to simplify. So in here, it said that you simplify the answer. You arrange all the variables with x on side to the one side of the equation, and whatever the c on the other side of the equation. So I will have 7 over 2y squared subtract 5 over 3x cubed equal to c2 minus c1. And c2 minus c1, all you have to do in this case is you are going to write it as just the c, okay, the general c. So a few ways that you can express the solution for this. So if you want to simplify this further, and then you are going to write it as, okay, I will take common denominators. So I will have 21y squared subtract 10x to the exponent 3, everything divided by 6 equal to c. Alright, then I can write it as 21y squared subtract 10 times x to the exponent 3 equal to 6c. Alright, okay, so you can express your solution in a few form, and I think sometimes it's better just to stop right here. Alright, unless they ask you to go further, and if you write it like this, you write it and everything is correct. Alright, because c is arbitrary, okay, could be any at all. So with c1 minus c2 minus c1, all I can just write is just c. Alright, okay, so let's continue with the next example. So for this example, I already have this as dy over dx for you, okay, and what I'm going to ask you to do is remember this. You need to somehow having the differential factor dy with the y on one side of the equation, the differential dx with the term of x on the other side of the equation. So again, I will simplify by dividing both sides of this equation by dy. I will divide both sides by dy, okay? And then at the same time, I multiply dx over to the other side. So I can immediately write it like this. Alright, okay. So now you see, you already separate the variables. Separation of the variable means the differential factor dy will go with the term y. The differential dx will go with the term 7 minus x with the expression that involving x. Now I'm going to integrate both sides. All right, so integrate both sides. So when I integrate both sides, I can definitely integrate this. I can also definitely integrate this. So don't worry that you have that dy doesn't multiply by 2y, because you can always integrate dy divided by y. So it will become a ln. Okay, so this also the same thing. It will become a ln, but don't forget you have a minus in front of the x here. Okay, so in this case, what I'm going to do is I will do step by step. So what I do is I will bring a half across the integral sign first. Okay, and for this part, what I'm going to do is I'm going to let u equal to 7 minus x. Okay, so don't forget, you are dealing with a function as a denominator. Okay, the factor dx is on top, and your whole expression is at the denominator, or your function is at the denominator. So you need to let this equal to u. So immediately after, you are going to differentiate. So this will give you a -1. Okay, so I'm going to do this. I will bring this over to the other side. Then I will have the this one as minus dx. Okay, but don't forget you just want the dx. So what you want to do is you will put negative du equal to dx. Okay, so you want to match this with this. So you are going to replace the dx with the negative du. Alright, okay, so I'm going to replace the dx with the negative du. So what I'm going to do is I am going to, here, I will replace it by this integral of u, right? Because you already replaced the denominator by u, and this will become your negative du. Then you can bring this negative across the integral sign. You will have du over u. So what is your du over u? Is your ln of u. So now I am going to put this in like a clown, and this will become negative ln of u, absolute value, and this one will become a half, okay, ln of y, absolute value, and this is equal to, so I will put plus c1 plus c2. Okay, so let's give it some room. Plus c1 equal negative ln of u plus c2. So what I'm going to do next is I'm going to replace this by negative ln of 7 minus x, and then c2 subtract c1. Now I need to bring this over to the side. Okay. C2 subtract c1. So what do I have next? Is to rewrite this in terms of just c. So I can go ahead and just write it as c. And then I'm done. Okay, all the term involving the x and the y variables goes on to this part of the equation, and just c stay on the right hand side of the equation. Alright, so this is done. Pretty simple. Okay. So let's try again by just quickly going over this. Okay, so for example number 1, what we have done is when you cross multiply, you are having dy multiply 7y, you have dx multiplied by 5x squared. So this is pretty simple. For this one, what you have is when you cross multiply, you only cross multiply this part. you divide both sides by 2y, and then you multiply dx over to the other side of the equation, right? So what I basically do is I take dy, I divide it by 2y, I divided both sides by 2y, okay? I divide both sides by 2y. So dy over dx, I divide both sides by 2y. So I divided by 2y, that means I multiply by 1 over 2y. Okay, so this part here, I multiply by 1 over 2y. So that means I do the same thing on this side, okay? So I multiply by 1 over 2y on both sides. So you see this one cancel with that. Now I multiply both sides by dx. Okay, you see this cancel with this. And then I end up with this. So that means I have dy divided by 2y, and then dx divided by 7 minus x. All right? Okay. So, and don't worry if you have your differential factor as a numerator and your expression here, part of your integrand as a denominator, you can always integrate this. Okay, so this will become a natural logarithm. All right, okay, so now let's go to example number 3. This one is a bit complicated. You may have to use a few logical steps in order to separate your variables. So what you need to do is, you see right here you have 5e raised to exponent 3x, and then you have dx already. So that means you want to get rid of cos of y. So you may want to divide the whole thing by cos of y. So I will do that first, okay? So right here, you see that I will divide it by cos of y. So in here, I want to get rid of the e to the exponent x on this side as well, because I don't want the e to the exponent x multiply with the dy. So therefore, if I divide this by cos of y, I get rid of this. Then I divide it by e to the exponent x to get rid of it. Then I might as well divide each term of the equation by e raised to the exponent x times cos of y. Okay, so let's do that. So I have 5e 3x cos of y dx plus e to the x secant of y dy equal to 0. Okay, so that means I divide both sides by cos of y and then e to the exponent x. Okay, I can do step by step, but I don't have enough room, so I am going to let's see, I give myself plenty of room. So what I'm going to do is I rewrite everything. Okay, so 5 e to the 3x cos of y dy. I divide this by e to the x cos of y dy. Okay, not dy. I only divided by that. Divided by cos of y times e to the x. So this is plus e to the x secant of y dy divided by e to the x cos of y, okay, equal to 0, because I need to divide this by this as well, okay, because I need to apply the logical step. Because if I divide one term by this whole expression, I need to divide every term by this expression so that I don't change anything in this equation. And if I divide by this into 0, and it just becomes a 0. But still logically that we need to write that. Okay, so that cancel with that cancel with that. And I can simplify this and this. right? So I can write it here, e to the 3x divided by e to the exponent x will be e to the 3x subtract x, right? So you have the same base, so then it will turn into e to the exponent 2x. So you have the same base, right? So you just write the base and then you subtract the 2 exponent. So this is the algebraic step that we need to remember. And the formula for that would be a to the exponent m, a to the n. You write just as the base a, and then you subtract the exponent. So in this case, you just have the same base as e. So now I'm going to write this as 5 e to the exponent 2x, right? And then I already cancel out the cos y, so I will have this as dx. Okay, so I'm sorry, I make an error here. I write dy, but it's supposed to be the dx. Okay, so I rewrite dx here. Okay, so that dx. Then here what I have is, I have secant y cos y dy. So what I'm going to ask you to do is to go to our formula sheet, okay? Because eventually what you need to do is you need to integrate, okay? You need to integrate. So what you have to do is you are going to find the integral that has something to do with your secant and your cos and all of that. But I can tell you that there isn't any formula that involving the cos of an argument that stays as a denominator. Then we have to do something with this secant y divided by cos of y. We can use the trig identity to convert that into something that we can integrate. So let's go to our formula, and then we can see which one that we can use, okay? So like I mentioned earlier, that, see this formula we used earlier, du divided by u will give us a ln u, okay? Derivative of e to the exponent u will be exact same thing again, and we know that we are going to apply these formulas. So now let's go through to see if we have a cos of something, but it has to be the denominator. Okay, there isn't any. There isn't any. Okay, there isn't anything that cos but involve a denominator. So therefore, I would like you to take a look at this. Okay, so if you have a 1 over cos, it becomes a secant. Okay, then what do we have a secant here? We are having a secant square. So what I'm going to do is I'm going to ask you to convert your secant y here, and we are going to write this as 1 over cos of y dy. Okay, we write it like this so that you know that this becomes a secant y. So this will become a secant y. So we have, so this becomes a secant y times secant of y dy equal to 0. So this will be plus secant square y dy equal to 0. Okay, so there is a formula for you to integrate the secant square y. So the integral of secant square y will become your tangent of y. Okay, so let me circle that formula that we are going to use. So which is this formula. This formula that we are going to use. Okay, formula number 5. And we have to apply this formula as well. Integral of e to the exponent u du is equal to e to the u. Don't forget it's the u. So you have to do substitution here. So in this case, your y is just the u. So therefore, it's a straight substitution of tangent of y. But we have to apply the differentiation factor du. And we also have to use substitution method for the other one. Okay, so for this part, what I'm going to do is I'm going to write the integral of all of this at the same time, I bring this across the integral sign, okay? So this one could be the integral of, I keep forgetting the c here. So equal to the integral of 0. Integral of 0 is just 0. Okay, so now I'm going to ask you to make sure that you need to let u equal to 2x. Okay, so then du over dx will be 2. So du divided by 2 will be dx. Okay, so therefore, what you are going to substitute is you are substituting 5 integral of e to the exponent u. So instead of write dx, you are going to write du over 2. Okay, so at this point, I hope everyone is an expert with the substitution method now. So therefore, you bring 5 over 2. So integral of eu du. Now you can go ahead and just write e to the u plus c1, right? So what is u? U is actually equal to 2x. Okay, so that is my my first integral. Now I'm going to bring this down all the way down because this is in fact equal to a tangent of y plus c1 plus c2 in this case, because I already used a c1. So equal to 0, because on this side the integral of 0 is just equal to 0. Okay, so the 0 still stay on this side of the equation. So therefore my final solution for this will be 5 over 2 e to the 2x plus tangent of y equal to c1 minus c1 minus c2 is just equal to just c, because they are arbitrary. It can be any constant, so we just write them as just the c. All right, so 5 over 2 e to the exponent 2x plus tangent of y equal to c as my final solution for this differential equation. Okay, so solving for differential equation is quite challenging. We had to review integration. So let's, I do have a couple of minutes left. I just want to review what I have done with example number 3, I'm sorry. Okay, I went over example 2 already, but for example number 3, I just want to ask everyone to remember that right here you have e to the 3x, you just need to have the dx with it. Okay, so here secant of y, you just have to have the dy with it. So somehow you have to get rid of the cos y on this term, and you have to get rid of the e to the x on this term. So it's very simple. You divide each term in this by e to the dx times cos of y. So when I divide it by, and I use algebra, okay, then I end up with the 5 times e to the exponent 2x dx secant of y dy over cos of y. But I want to write it like this. I write it like this because the same as you multiply by 1 over cos y, then you use trig identity. Okay, so this is the trig identity. So 1 over cos of y equal to secant of y. And you substitute that in here. You will have secant y times secant y equal to secant square of y. And when you integrate, this will, you just have to use the formulas. Okay, then what do we do next? We integrate each term. And then don't forget this is a substitution method. So you can pull out the half here. And in the end, secant square of y dy will give you tangent of y. And you add c to each of these, and then you move all of it over to the other side and make that just equal to c. So this is the solution of this first order differential equation. All right. Okay, thank you everyone. Don't forget to work on the exercise, and I will make a video for the exercise as well.